Right, the bearings on page 42 of your notes. Okay, have you come across bearings before?
Yep.
Okay, have you used trigonometry within bearings?
Yep.
Yep, alright, so that's what we're doing in this section. Alright, bearing. Okay, so everyone's seen a compass. So a bearing is simply a measure on a compass. Okay, so we start from a compass. Okay, so pointing straight up is typically north. Then to the right, clockwise, we go east, south, and west. Okay, never eat soggy wheat bix. Alright, that will be one way to remember the rotation there. Okay, or however you're going to remember it. Okay, so true bearing. Okay, so bearings are used to measure angles on a compass. Okay, so not just referring to north, east, south, west, or a combination. So for example, southwest or northeast or north, east, north, north, northeast. Okay, that's another typical one we can do. All right. We are going to use numbers. Okay, so bearing is a triple digit number. Okay, which gives you a measure on the compass. Okay, so north, which is also called true north. Okay, has the bearing 000. Okay, now we should all know that it's a right angle between all those four sides. Okay, so what would be the bearing of east?
90.
Okay, so in a 3-digit, 090 degrees. Okay. Alright, south then will be what? South will be what? 180. West will be 270 degrees. Okay, and then back up to north, which technically we can have as 360. Okay, or we simply reset it back to 000. Okay, which means the same thing. Okay, so we measure clockwise from north. Okay, so if we're referring to a bearing 100 degrees, for example, okay, we'll be in the 4th quadrant. Okay, using number plane. Okay, so let's label those. This is first, this is second, this is third, and this is fourth. Alright, and you'll see more of that when we do linear relationships as well as your functions and graphs. Is that a question, Amanda?
Is this page 42 or 44?
43. Bottom 43. So, bottom 43. So, page 43, right down the bottom. So, was that a question, Amanda? No? You're good? Okay, so they're the quadrants, okay? So we refer to that when we're doing linear graphs and world functions and graphs when we get to that topic next. Alright, examples. Alright, let's look at some. Alright, D. Alright, so we've got an arrow. So you should always be told which way is north, at least. Okay, which would typically, 99 times out of 100 you'll see it will be pointing straight up. Okay, because you're looking on top of a view of something. Okay, and now you've got a line out there with an angle of 126 degrees from north. Alright, so we're N, we have P at the centre, and Q out here. Alright, so we need to write down the true bearing of Q from P and vice versa, so the true bearing of P from Q. So, the first part of it, so bearing of Q from P. So, that word from, okay, is your starting point. Okay, where you see the word from, that is where you start. Okay, so we're starting at P. So from P here, okay, we've got true north facing directly up, and we've got an angle of 126 around to Q, so therefore the bearing of Q from P is 126 degrees. Okay, the bearing of Q from P. Okay, now vice versa. Okay, So we need the bearing of P from Q. Okay, so that means now this is our centre point. Okay, this is our reference point, so we need to put another compass on top. Okay, so that's north. Okay, so we need to now work out the angle clockwise from north that that line forms there. Okay. How are we going to work it out first and foremost?
Is it going to be the opposite?
Is it 360 taken away 126?
Yep.
No, not quite. Yes, you're on the right track in terms of 360 takeaway, because if we find the value of the angle here, and we take that away from 360, that's going to give us the angle there, isn't it? Okay. What can you tell me about the two north? They're parallel. So what do we do in geometry?
Yeah.
Yes, alright, so we use our geometry skills here, okay, to do co-interior angles, okay, or other angles. Okay, so 126 plus 4 is 30, and then another 50 gets us 180. Okay, so that angle there is 54 degrees. Alright, so you need to write down a bearing. Alright, so P from Q is going to be 360, take away 54. Okay, you can also work out the angle from here to here. Okay, using our geometry skill, whatever would be more straightforward to do, and then we simply add that to that straight angle down there. Also, the 270. Out here, 270, plus the size of that angle. We can also use our geometry skills, okay? However, it would be more simple to do that one there. Alright, so 360 take away 54 is 106 degrees, okay? That's the bearing. Alright, so we know we're in the second quadrant, alright, because it's greater than 270, less than 360, so 306 will be the bearing of P from Q. Alright, E. Alright, so now we're saying that your geometry skills are now incorporated into trig. Even though bearings is not trig specifically, however we will be looking at trig application of bearings shortly. Alright, so that angle there is 130 degrees. So we have P at the vertex, Q, and the same, okay? So we need to find the bearing of Q from P. So where the word from is, that's your reference point, okay? So from P, that first part, okay, which is at the centre, so Q from P equals. Alright, so what's the maths I need to do to work out the bearing?
360 take away.
Yes, alright, because now we're going in the anti-clockwise direction because you're given the angle that way, okay? So when you do an anti-clockwise, you do a subtraction. So that's 360 take away 130, so that's 230 degrees. Another notation as well, while I've got in my mind, is after that they put a capital T. So that's what's referring to from true north. Okay, so whenever you see that, it's the same application as what you've done here. Okay, so that T just simply means from true north. Alright, and you might see that in questions and assessments in your textbook, etc. Alright, P from Q. Alright, so now we need the angle from here. Alright, so there's north in the same direction. Okay, so like we determined last example, those two lines are parallel. Alright, so you need to use some geometry skills, some vertical opposite angles or parallel line properties to determine the value of another angle so that you can work out the bearing. Alright, so what's the maths I can do? So co-interior again. Okay, so I'm not testing you on your co-interior alternate, I'm not testing you on that. Okay, so you can simply write it down. I'm just testing you to see whether you can tell me a correct bearing. Okay, so you don't need to state the value of that, give a reason, like we did in the last topic, because that was the question there. It said give the value of the following pronumerals or the following angle, given reason. Okay, this question is just saying, fine, give me the bearing from these two, this point from that point. Okay, so you don't need to go through the proof. Okay, you can take this as assumed knowledge, unless they ask you to prove it. Okay, or give a reason. Alright, so simply remember we got a triple digit reading, so writing 50 is not correct entirely. Okay, you need to write it in 3 figures. Alright, and again, we can have that notation true north. So why don't we just write it there so that we are familiar and we're not having any surprises. Alright, F. Alright, so in all these questions, you should be told where true north is. Okay, and you should be given other information in the diagram. That's P and Q. Should be given other information in the diagram to be able to answer the question. Okay, you might need to go through your geometry skill and do some work before you have an answer. Alright, so Q from P is what?
What are those numbers?
Yeah.
Okay.
What are those numbers? 31.
So 0.
Better?
Yeah.
Okay, to the bearing of Q from P. Okay, so remember the word from is our reference point, P is our reference point. Okay, and it's nice and simple, hopefully, for everyone to see that 0.1 degrees from true north. Okay, so put a capital T after it. Alright, other way around. P from Q. Alright, so from Q, so when you get a reference of that, you need to ensure that there is a compass there. Alright, label it appropriately. Alright, so there's a couple of things we can do. Alright, so what would be one suggestion of what we can do in the question?
Alternate angle.
Good, okay, so instead of using co-interior angles here and do a subtraction, okay, we've got straight away, we've got the alternate angles there, Z shape. That's 51 degrees there. Okay, so we've got the straight angle from clockwise, we've got 90, 180 plus the extra bit in the third quadrant, okay, plus 51. So 231 degrees from true north. Okay, is everyone following, everyone understanding how to do these? Okay, they will step up because you will have real life application problems involving bearing that you'll have to use your trig skills. Alright, but we're just making sure we can do a bearing reading first. Alright, G. Okay, north. And now we've got a Q out here. And the angle in there is 24 degrees. Okay, so again, you should be told where north is, always a requirement in the question. And also when you label diagrams, you should always be putting the north there. Alright, so we've got Q from P. So again, the word from is your reference point, so from P. Okay, so we've got the straight angle there, plus that extra little bit. Okay, so 180 plus 24. So it'll be 204 degrees from true north. Okay, and now the other way around. P from Q. Right, so there's the compass on Q. Alright, so I'm going to label north. So how do I work out the bearing from of Q? So of P from Q. Okay, again, we've got another Z shape, back to front, there. Right, that means that angle there is 24 degrees. Right, and then from north, because you're in the first quadrant, nothing plus 24. Okay, so 0 to 4 degrees from true. Okay, everyone's got that down pat now? Alright, now let's try some further examples. Alright, so now some problem solving. Okay, a ship sails due north from port A to port B, a distance of 150 kilometres. It then sails due east to port C. If the bearing of C to A is 0.48 degrees from true north, we need to find out how far the ship is from A. Right, now, sometimes these diagrams will be provided, sometimes they won't. Okay, so this couple questions here they are. If they're not provided, that means the first thing you need to do is to be able to draw a diagram. Okay, so one's provided, but let's go through the question. So a ship sails north. So put the compass there first, and we'll go through the question. A ship sails due north. So when it says due one direction, it means it keeps going in that direction. Okay, from port A. So from, that's our starting point at the centre, alright, to port B. So let's put a point here, B. So it sails due north from point A to point B, a distance of 150 kilometres. Okay, so between A and B, 150. It then sails due east to port C. Alright, so we're going in an easterly direction. Alright, now this one doesn't tell you measurement, that's why we say due north, due south, due east, due west. So it goes in an easterly direction until it reaches a point up the port C. So a lot of these questions will be referencing a ship sailing around somewhere in the water of the world. Okay, to port C. So if the bearing of C to A is 0.48 from true north. Okay, so we need to put that line there. If the bearing of C to A is 0.48 true north, alright, so that means this angle here is 48 degrees. Okay, so 0.48 is the line from A heading up towards C, alright, and that makes that angle of that triangle. Okay, so we've gone due north, then due east, means we have a right angle there. And the question asks us, find how far the ship is from A. So we've gone from A to B to C, we now need to find this distance here. So it is now your right angle triangle trig application. So after you have drawn a diagram, just labelling that information, okay, the next thing I would suggest you do is I would draw that bigger triangle that we got here, 150, there's the right angle, there's 48 degrees, and we need to find that distance there. Okay, just to tidy things up a little bit. Okay, so just reproducing this diagram over there, and now you can introduce any variable you want. Okay, so I've called it x, you can do whatever you would like. Okay, and now we have a right angle trig problem. Okay, so step one, we've drawn a diagram with the information. Step two, let's label our three sides. Okay, so we've done that before when we looked at examples of right angle trigs. Right, step three, choose the appropriate ratio. So we know how long the adjacent side is, so I'm going to use that. My hypotenuse has a variable. Okay, for this particular question, the opposite will not be used. Okay, so which of my three ratios, sine, cos or tan, uses adjacent and hypotenuse? Because theta is equal to A over H. Because of the angle inside the diagram, which is 48 degrees, is equal to A, which is 150 over X. Right, again, this is an application of equations, so you have learnt the skills, you are now applying them in different topics. Okay, so if we don't remember we don't remember how to do equations or we want to do it more quickly, okay, if the variable is on the bottom of the fraction, you swap it, okay? Because you'll need to multiply it and then you need to divide, so you can just do a swap. So x is 150 over cos 48, which is...
Negative 234.
That can't be correct.
Did you put it in your calculator, right?
Yes. No, she was saying it for fun.
224. How'd you get a negative?
So last night I was
So do it again.
I was like, how does the calculator know all the numbers?
And what did I say at the very start of the topic?
What?
What did I say at the very start of the topic?
Oh, you have to have a certain setting on it. You have to have it. Don't have, oh, gotta have it here.
Okay, you got a little R on the top of the calculator, which is radian measure, which you won't be looking at until the HSC course. Okay, you calculate in percent degrees.
Okay, yeah.
Alright, so find how far the ship is from A. So the thing I haven't done in the question, or I haven't specified any rounding, alright, so I probably should have. So what do we get for our answer?
224.
Okay, is that a rounded answer?
Yeah.
Yep, okay. Now I should probably have said to the nearest kilometre, or that should be stated in the question. Okay, otherwise I will stop marking at this point here. Okay, because that is in simplest form. Alright, I'm going to write next to it nearest kilometre. Okay, Alright, so I'm going to read. When you are doing these questions, I would suggest you read through the whole question first, and then read through the question again and start drawing a diagram. Okay? So, a plane starts from airport C and flies 226 degrees from true north for a distance of 120 kilometres. We need to find how far south and how far west of P it is to the nearest kilometre. So, let's start again. So, draw your compass with your reference point. So, the plane starts from airport C. Okay, so the starting point is at the centre. And flies 226 degrees from true north. So, which quadrant would the plane be flying in? Right. Third quadrant, okay, so remember 90, 180, 270. Alright, so it's going this way somewhere. Now, it does not need to be accurate, these diagrams, okay, so they may not be representing 226 degrees from true north, okay, because we're not relying that diagrams are to scale, okay. So, for a distance of 120 kilometres, alright, that's why diagrams need to be big so they can be labelled and not squashed. Right, so we need to find how far south. Okay, so we need to find this distance here, how far south it is, and we also need to find how far west. Okay, so how far this way it's gone, how far that way it has gone. Okay, so to achieve that, I can draw a right angle triangle like follows. Okay, so I'll find this distance and I'll also find that distance there. Alright, so now we need to work out the angle inside the triangle so that we can do a trig question. Alright, so the bearing was 226. Okay, so that means that measure is 226 degrees from true north. So how am I going to work out the size of the angle inside the triangle?
226 take away 180.
Good, okay, so we've got the straight angle there. Okay, we've got the extra little bit, so we take that, our bearing, take away 180, that will give us that remaining angle in there. Alright, 46 degrees. Okay, it's not 46 degrees from true north, okay, you are now just referencing an angle inside a triangle. 120 kilometres and 46 degrees. Okay, so we need to find how far south, so I'm going to label it with an S for south. Okay, and how far west, I'm going to call it W for west. Okay, so now drawing my diagram again without the distraction of all the other things I've labelled. 120, this is 46 degrees here. Alright, this is S and this is W. Okay, so we got the hypotenuse. Okay, the letter W is on the opposite and the letter F is on the adjacent. Okay, so this will be two things you need to do. Okay, doesn't really matter the order. Okay, I'm going to do south because that's what it's asked me to do first. Okay, so I know the adjacent and I know I've got the variable on the adjacent and I know the length of the hypotenuse. Okay.
I don't understand. Okay, it's
What?
probably really simple, but I don't understand how calculators know all the numbers.
For the time being, Amanda, just think of it as a 1 mega computer that can process very well and very quickly. Okay, and when we get to the HSC course, I will be able to explain more about that when you've learned some maths about it. Alright, and we'll find out some more about it. Okay? And also, Amanda, think about maybe back to your parents when they've been at school, they didn't have a calculator. Okay, so you think about how they did it and how we can do it now.
Their brains?
Hey?
They use their brain.
Yeah.
It doesn't have a brain.
Got a computer brain.
It's got a battery.
Alright, because theta is adjacent over hypotenuse. I thought you were having an issue with the question, not an issue with the
No, I like
comprehension.
it, stuff.
Good. I do too.
But you still don't get the oh.
So it sounds like your homework tonight is going to be how do calculators work. Alright, cos 46 is equal to S over 120. Alright, so when the number is on the bottom, you bring up and multiply. Remembering, alright, when you do that, you put in the number out the front, okay? You've got to be very careful with your syntax, how you put in your calculator, if you're going to do cos of 46 degrees times the length of 120, and it does not read it as cos of the angle of 46 times 120, okay? So I suggest you put it out the front. Alright, so it says to the nearest kilometre. So how far south is it?
83.
Hey? 83 is the nearest kilometre. Alright, one of two things we can do now. Okay? One, we can do trig again. Okay, and we're going to do that because we are on the topic. Or, what's another way I can answer this question now? Okay, why would I choose to do trig and not Pythagoras?
Because you've been tested on.
If this was just a general question in an exam. If this was in your yearly exam. Okay?
Just in case you got that wrong.
Okay, good. If you did not get this correct, okay, you are using this calculation, using Pythagoras, to get the length of your other side. Okay? So, hopefully we don't get these incorrect. Okay, we really shouldn't. Okay, but however, I'm going to use trig again because it does not rely on this variable here. Okay? So, we have sine of theta, which is opposite over hypotenuse. Okay. And also, because we've rounded already here, okay, it might be incorrect here. Hello? 4.
Does the school know you're here? Does the school know you're here?
I take your car, please.
It's in my man bag. Alright, sine of 46 degree. That was my wife in case you haven't picked that out. Is W over 120. So W is going to be 120 times sine. So we've rounded this answer here as well. Okay, so this is again a rounding error. Okay, so this might not be rounded correctly because you rounded early. You might not have the correct answer because you rounded early, and that's an example of why we need to be careful about our rounding to answer the question and not round until we have our final answer.
Oh, wait, sorry, I'm back in slowly because it's starting.
Yeah, this is Angela, that's Michaela, you know Amanda,
Yeah.
it's Robin and Josh.
Where's your car?
Front.
Okay, cool. Just start a car around for like
What do you need?
Food.
Hey?
Going in your car, that's all.
The what?
It's just food going in your car. Call me when you want to please back. I'm not gonna come back later.
I'm not leaving until about 5.
Yeah. Cool. Alright, bye-bye.
Equals. Not weak, far from it.
Why? Well done.
Alright, what do we get?
86.
80.
6.
Okay. Out of curiosity, can we please do the square root of 120 squared, take away 83 squared, please? So if we were to go ahead and do this in Pythagoras, what do we get as our answer?
Is 86.
Rounded to the same number?
6, no,
It's
87.
87.
87, exactly, okay? So this is why you don't round early, okay? And also why you make a sensible choice in terms of how you're going to answer your question, okay? You can do this, okay? You just have a rounded answer here, okay? If you have 2 or 3 decimal places, you can then put it in here, okay? Because you need it to the nearest whole number. Once you have at least 2 more decimals than what you need, okay, you can then carry it into the calculation and you should be sweet for your final answer, okay? That's what I was testing you on that last question in terms of that stick in the box, because if you had rounded early, you were going to get the incorrect answer at the end, okay?
You did get an incorrect answer at the end.
That's what I wanted to get the point across, okay, with an example.
You do it well.
Good. For those who actually got the answer, yes. Alright. Question? We really need everyone here because this is new. Got 15 minutes, which is an annoying amount of time. Very annoying. Alright, I'm going to stop there. I don't really want to go on further because it all incorporates. I want to go through a lesson and go through all the theory. Okay, so you've got 15 minutes. Ask a question, etc., etc. Okay, and then we get this done, and then tomorrow, hopefully everyone's here. If not, I'm going to go through it anyway, they can catch up. We've got a lot of theory to do tomorrow, a lot of new stuff as well, okay?